because what we're starting today is Chapter 7. Now, Chapter 7 is going to be starting our rational functions and expressions. Now, when we talk about rational functions and expressions, well, we've talked about rational before, because we talked about rational numbers at the beginning of the year in August. And we talk about a rational number, well, we're talking about a number that can be written as a fraction. So 4/7 would be considered a rational number. So when we talk about rational functions or rational expressions, we're talking about an equation that's going to have a fraction, or more specifically, have a variable in the bottom of a fraction. Now, they can be in the bottom and top of a fraction. That's perfectly fine. But they will specifically be in the denominator. That's why we talked about polynomial functions, where if the equation had a variable in the denominator, we didn't call it a polynomial function because it has rational. That part of the function would be rational. So that's what we're going to be talking about. Now, before we delve into that, we're going to talk about direct and inverse variation first. We'll be talking about a direct and inverse variation. Now, direct variation, you have learned that two variables show direct variation when y is equal to a times x for some non-zero constant a. And another type is called inverse. Now, when we talk about direct variation, just as a reminder, direct variation means as one increases, the other increases. As one decreases, the other decreases. So either they're both going up or both going down. Let's see here. Okay. Pull this up. Got to pull up a new tab. I'll have to edit that later, but that's fine. Pull up Desmos graphing calculator. Because what we could say is y equals 2x. See if it'll let it do it. Y. Okay, it's not going to let me type that way. That's fine. Y equals 2x. Come on. This here would be considered direct variation. And as we look at it, as we go to the left and x is increasing, the value of y is increasing. As we go from here down, as the value of x is decreasing, the value of y is decreasing. They're going in the same direction. And this would be considered a direct variation. And we can also consider, so y equals a times x is direct variation. Or if we get x by itself, or a by itself, divide both sides by x, y divided by x equals a is also considered a direct variation. It's just manipulating the one equation to get the variable a by itself. And a in any of these here is just going to be considered a constant term. It's just a number. A is just holding the space for a number. So in either one of these cases here, we are still dealing with a direct variation. And we can see that in here, y divided by x equals 2. And it actually gives us the exact same equation. These here are going to be the exact same. So really with direct variation, as one increases, the other increases, or as one decreases, the other decreases. Now, inverse variation, what do we think is going to happen with inverse variation? As one increases, the other is going to decrease. And as one decreases, the other is going to increase. They're going to go in opposite directions. And the main equation that we have for inverse variation is y is equal to a divided by x. Now we could also multiply both sides by x to get a by itself and say that y times x is equal to a. So these here are kind of the general formulas that we have for inverse and direct variation. And a is just going to be a constant term. So realistically, direct variation, y is equal to a times x, or we can say that y divided by x is equal to a. In our inverse variation, we could say that y is equal to a divided by x, or that x times y is equal to a. And both of these here would be considered direct or inverse variation. So the two in red are both direct, and the two in green are both inverse. Any questions on this so far? Other direction? And in both of these cases, our constant term cannot be 0. Constant term, the number can't be 0, because anything times 0 is 0. It really doesn't tell us anything. So let's look at these first three here. So the first one, x times y is equal to 5. Would this be direct, inverse, or neither? I would agree with inverse. Because if we look at the forms that direct and inverse come in, direct is either going to be in the form of y equals a times x, or a is equal to y divided by x. Well, this here is neither one of those two forms. If we look at inverse, the inverse equation, y is equal to a divided by x, well, that's not it. Or it can be in the form of x times y, or y times x equals a, and that is the form here. Now, if we wanted to with this equation, we could divide both sides by x, which would give us y by itself, and it tells us that it's equal to 5 divided by x. So it would be this inverse variation. Any questions on this here? Now, I didn't do this with last hour, but I'm going to do it with y'all. So let's see here. It's probably still. Nope, not going to type that in. Nope. That's fine. Here, they gave us the equation x times y equals 5. And we have this here. Now, as we look at this here, as the values of x increase, what's happening to the values of y? They're decreasing. And here, as the values of x increase towards negative infinity, what are the values of y doing? They're actually getting closer to 0, yes? Even though they're both negative, because we can talk about this here going in the negative direction, x is increasing to a bigger negative, and y is increasing to a smaller negative. Or if we go the other direction, starting negative 35 and approaching this way, x is reaching a smaller negative, and y is getting bigger. It drops all the way off the map. They're going in opposite directions. And when x is 0, there is no value. X can't be 0. So this here would be inverse. So any other questions on A before we skip B and go to C? We'll come back to B in a minute. Now looking at C, would this be direct or inverse variation? Or neither? It's kind of hard to tell, isn't it? So we do know the first one's inverse, yes? So let's look at doing y divided by 2 is what we have, yes? And this here is equal to what? That's a straight line, yes? So as x increases, y is increasing in this direction, yes? And as x decreases, y is decreasing. What would that be? Direct variation, yes? So let's look at it numerically. So one thing that we could do is I can actually multiply both sides by 2 to get it in a way that looks a little bit better. 2 times y over 2, well, the 2 and 2 would telling me that y is equal to 2 times x. That is one of the setups for direct variation, isn't it? Y equals a times x. So we can say that this is a direct variation, yes? Okay. I'm going to erase this here. One half, or y divided by 2. I can write that as what times y? Well, we can rethink of this as what? 1 over 2. Because it's 1/2 times 2 the same as y divided by 2? And direct variation is what? Y times x, or so y is equal to a times x, yes? One constant is equal to a number times, or the other variable, not constant. So variable equals to a constant times the variable, yes? Isn't that still the same thing we're saying right there? But instead of the constant term being multiplied by x, it's being multiplied by y. It's still talking about the exact same relationship. It's just set up in a different form. Any questions on this here? So if we're having a little trouble looking at it, we can get it to where y is by itself. It's a little bit easier to see by multiplying both sides by 2. Any other questions on this here? Let's look back at letter B. What do we think about this one here? Direct, inverse, or neither? It is neither. And the two big giveaways, one of them is the x minus 4. Because if we look at all of these here, all of the different versions of direct and inverse variation, what is x and y doing in any of these where they're on the same side of the equal sign? They're being what? Multiplied or divided, yes? And if they're on opposite sides of the equal sign, well, that variable and the constant term are either multiplied or divided, yes? In all of these here, we're working with multiplication or division, and we do have either a constant term by itself and the variables all on one side, or variables on either side, yes? So with variables on either side in that addition or subtraction, it's really telling me that it's going to be neither. It's going to be neither. I'm going to add a fourth one in here. I'll go at this. We'll go at this a little differently than the last hour. I will tell you one of these 4, even the one that I added, only one of them is neither. Which one's going to be neither? Number 3. I added the fourth one in to be a little bit deceptive, but it is not neither. Now let's look at these from the top. We'll look at 4 last. So looking at number 1, would this be direct, inverse, or neither? Direct, because this is coming in the form of y equals a times x. So exactly, this would be direct. How about number 2? It would be inverse. Because it is coming in the form of x times y is equal to a. And if we wanted to, we could have rewritten it as y equals a divided by x. Y is equal to negative 0.25 divided by x. How about number 4? It would be inverse, yes. Because if we wanted to, and what we could do is actually add 10 to both sides, getting the variables by themselves, x times y is equal to 10. We can also kind of have an understanding that a is not 0. Because by definition, for inverse or direct variation, a cannot be 0. So the fact that x times y is equal to negative 10, x times y minus 10 equals 0 really doesn't work because a cannot be 0. We move the 10 over. Now we do have it in the form of x times y equals a, and it does work as an inverse. So really, x and y cannot be split up with a plus or minus. Any other questions on these here? We'll finish up this part with these last 3, and then we'll move on to the next ones. So the first one would be inverse. The next one would be neither. And lastly, direct. Yeah, because we can think of the last one as y is equal to 10x, or 1/10 times x. 1/10 times y is equal to x. Any other questions on these here? Okay. Now our next type is looking at a chart. So they give us a chart of numbers, and we want to determine whether they are direct, inverse, or neither. Now we have been given 2 equations for direct and inverse variation. Because direct variation comes in the form of y equals a times x, where a is just a constant term. Yes? But we also have that y divided by x is equal to a. So all the numbers for a direct variation, y over x, should have a constant term, a, between them, yes? And the same is true for inverse, because y times x equals a constant term, a. Because for any direct or inverse variation, there is a constant term or a constant change for both. Either they're both increasing by the same amount, both decreasing by the same amount, or kind of going in opposite direction by the same amount. That constant term a will remain the same for any of these here, given it a direct or inverse variation. But if there's not the same, it's going to be neither. So if we want to look at this first one for direct variation, well, we can say negative 12 over 2, because negative 12 is just one of the y values, and 2 is its corresponding x. And what is negative 12 divided by 2? Negative 6, okay. Well, the next y value that we have is negative 6 divided by 4, its corresponding x value. which is negative 1.5 or negative 3/2. Either one is fine. Are those the exact same? No. So it is a direct variation. Well, no, because if it's a direct variation, this here, y over x, which is our direct variation, should have the same amount. It should be increasing or decreasing by the same amount. Well, here, we can say that the increases are at different values, different spots. The amount of change is not the same. So let's try multiplying them together. Well, 2 times negative 12 is negative 24. Okay. 4 times negative 6 is, okay, that's kind of interesting. 6 times negative 4 is, and let's go on and try the last one. 8 times negative 3. So is the constant term a the same for all of these here? Yes. So that's telling me for this here that this would be an inverse variation. Because as x is getting farther away from 0 or getting closer to infinity, it's getting bigger, while the values of y are getting closer to 0. One is going to infinity or getting bigger, the other is getting closer to 0. So it would be considered an inverse variation. Questions on this here? Let's look at the next one. Y over x equals a, or y times x is equal to a. So we can try direct variation first, so we can say that, well, 2 divided by 1 is 2. The next one would be 4 divided by 2 is 2. Hey, this looks like direct variation, yes? But let's go on and try all of them just to make sure. Well, right over the top. The next one would be 8 divided by 3, which is 2.6 repeating, or really just 8/3. So wait a minute, are all 3 of them the same? No. So this is not direct variation. All right, let's try inverse. 1 times 2 is 2. Yeah. 2 times 4 is, well, that didn't work either because we need the amounts to be the exact same, yes? So what is this one going to be? Neither. Neither. It's not direct or inverse variation. It's actually a quadratic equation, if we were going to put a name on it. Questions on this here? All right. Let's look at 2 more of these because I think probably 2 more and y'all have got a pretty good handle on this. Because in either one of these here, we're really just either using y divided by x is equal to a for direct, or y times x is equal to a for inverse. So which one do we want to try first, direct or inverse? Doesn't matter. We can try direct variation, so we can say 20 divided by negative 4. 15 divided by negative 3. Negative 5. Okay, this is looking good. 10 divided by negative 2 is negative 5. And 5 divided by -1 is -5. So we do have the constant term the same for y divided by x, which tells me that this here is direct variation. And as we look at this here for the x values, as they approach 0, as they are getting smaller, the values of y are approaching what? 0. They're both going to 0. So this here would be direct. Any questions on number 4? Let's look at number 5. So we can start off with direct variation. You don't have to start off with direct variation. If you have a feeling that one of them might be inverse, you can start off with inverse. So we start off with direct variation. We have 60 divided by 1, which is 60. The next one is 30 divided by 2, which is, okay, well, that ain't it. Because as soon as we get one that's different from the rest, we can stop, because they all have to be the exact same. Now we can try inverse, y times x. So we can say 1 times 60 is 60. 2 times 30 is 3 times 20 is, and 4 times 15 is, well, hey, they all have the exact same constant amount, so this would be inverse. So this here would be an inverse variation. Any other questions on these here? Do we feel comfortable with these? Yes? All right. Let's look at the last type of problem we're going to look at for today. Now, these questions here are asking for two things. One is they want an equation, and the second part is a value. Variables x and y vary inversely, and y is equal to 4 when x is equal to 3. Write an equation that relates x and y, then find the value of y when x is equal to -2. So the first thing we need to do before we find any values is we need the equation. Now the equation that relates x and y for inverse variation is y is equal to what? Well, a divided by x. This is the inverse variation equation. Now, x and y are going to be a part of it because we need those in the equation. The specific value we need is the value for a. If I know the value of a, I have the equation. Well, they did give us a piece of useful information, yes? What did they tell us? Yeah, y is equal to 4 when x is equal to 3. And what we can do is we can take that information and plug it into our equation, because they told us y is 4 when x is 3, yes? Did they tell us what a was? Well, no. But now I have 4 is equal to a divided by 3. I only have one variable in that equation, yes? And we can solve for it by multiplying both sides by what? 3. Because here the 3 and 3 would cancel, telling me a is equal to 12. Therefore, the equation is y is equal to what? 12 divided by x. So that is the inverse variation for this here, the equation that's relating x and y. Lastly, we need to find the value of y when x is equal to -2. Well, we can take this y is equal to 12 divided by x and do what? Well, x is what? Plug it in. And well, 12 divided by negative 2 is negative 6. And that's it. So really for this here, all we had to do was find the value of a from the given two values, plug it in to get the equation, then plug our x value in to find the value of y. Questions on this here? Be ready for the next one. The variables x and y vary inversely. Okay, if they vary inversely, we're saying that y is equal to what? A over x. And the reason we're using this one here is because this is a nice equation relating x and y. We're talking about relating x and y. We want them on different sides of the equation. And y is equal to 8 when x is equal to 4. Write an equation that relates x and y. Then find y when x is equal to negative 16. Well, they did tell us that y equals 8 when x is equal to 4. So we can start off the equation y equals a divided by x. To find the value of a, we can plug the two values they gave us in, 8 and 4, to solve for the value of a. Well, what can we do first? Multiply both sides by 4. Here, the 4 and 4 would simplify, telling me that a is equal to 32. So our equation is y is equal to 32 over x. So that's the first part of this here. The second part would be taking this here and doing what? Plugging in negative 16 for x to find the value of y. Well, 32 divided by negative 16 would be negative 2. So y equals negative 2 would be the second half of our answer. Any questions on this here? Do you feel comfortable with these here? You all need to see another example of one of these. If you all feel comfortable with these here, we are finished with 7.1. And that's all we're going to be doing for today.